In today's lecture number 2, we are going to practice questions which are based on the concept we have learned in lecture number 1. Let's get started. How many moles are in 25 grams of water? These 25 grams, they are the given mass. So they have given us the mass. Let's recap a little concept from the previous lesson. The previous lesson tells us that there is a little mnemonic to memorize the formula, which is Mn and M. There is a small r which stands for the relative molecular mass. This is actually the molar mass or the molecular mass. This one stands for the given mass, and this one is for the moles. So in order to find out a missing one, we must know the two other quantities. So we are provided with the given mass, and the molar mass we can find it out looking into the substance we are provided with. So we are provided with the substance which is water, so we can find out the molar mass of water. So Mr, which is the molar mass of water, which is equals to 2 cross the atomic mass of hydrogen in the periodic table plus 1 cross the atomic mass of oxygen, which is 16 in the periodic table. So we get 18 grams per mole. This gram per mole is the unit of molar mass. Now, using the formula, we have the two other quantities. So if we need to find out this one, if number of moles is our subject that we need to find out, then the one which are one above the each other, they will make a formula in a divided function. So number of moles, this is equals to given mass or mass over the molar mass, which is equals to given mass is 25 grams divided by 18 grams per mole. Now, let's do a little calculation to find out what is the answer. So 25 over 18, that is 1.38. Now the question is, what is the unit of this calculation that we have performed? So we see that this grams and grams, they will be cancelled out, and this mole will move up, and the answer will have a unit 1.38 mole. And also we were calculating the number of moles, so N has a unit mole. Now let's move on to the next problem. How many grams are in 4.50 moles of lithium oxide? Now the question is, we are provided with the moles, and we need to find out the grams, the given mass or the mass. So this is given data. This is the given data. We can find out the Mr of this molecule. So this is what we need to find out. And this is our subject that we need to find out. So this is the subject. Now, if mass makes a subject, then the other two quantities, since they are facing each other, they will multiply with each other. So the formula will take a shape like mass is equals to number of moles times the Mr. So again, we need Mr to be calculated first. So our first step should be the calculation of Mr. So Mr, lithium oxide, this is equals to 2 times the atomic mass of lithium. So let's find out in a periodic table what is the atomic mass of lithium. So this comes out to be 6.9 plus 1 cross the atomic mass of oxygen, which is 16. 2 cross 6.9 plus 16. We get 29.8. grams per mole. So mass is equals to number of moles times mR, which is equals to 4.50 times 29.8, or you can rewrite it as 4.50 moles cross 29.8 grams per mole. So we see that this comes out to be 134.1. What will be the unit? Let's find out. Mole will be cancelled out by moles and we are left with grams. And since we are finding out the mass, so the answer will comes out to be in grams. So these two problems, they are based on moles and mass interconversion. I hope you are clear about this. Now let's move on. In this problem, problem number 3, we are going to find out how many molecules are in 3.4 cross 10 power 23 molecules of sulfuric acid. We have a little convention that we have learned that 1 mole of any substance contains 6.02 times 10 power 23 number of particles. So here they have given us there is a little problem in here in the question. Let's fix this up. It should be moles. Okay, so we have corrected our problem. Now, 1 mole, we need to find out how many moles are there in 3.4 cross 10 power 23 molecules of sulfuric acid. So 1 mole equals to 6.02 times 10 power 23 number of particles, which is a set convention, just like dozen is equals to 10, 12, and pair is equals to 2. So 1 mole is equals to 6.02 times 10 power 23 number of particles. So we have this sulfuric acid whose number of molecules are 3.4 cross 10 power 23. So what will be the number of moles? That will become X. So let's make it into a ratio method. So we will be doing method number 1, which is a ratio method. So ratio method tells us that we have mole ratios the Avogadro's number. So 1 is equivalent to 6.02 times 10 power 23. So 3.4 times 10 power 23 will be equivalent to how much? That is X. So X is equals to 3.4 times 10 power 23 divided by 6.02 times 10 power 23. This is multiplied by 1 mole, right? So what do we get? We get 0.56 moles. And there is another method, which is method number 2. And in this method number 2, we have a method to find out the number of moles. So number of moles, this is equals to given number of particles divided by the Avogadro's number of particles. So given number is 3.4 times 10 power 23 divided by Avogadro's number 6.02 times 10 power 23, which is equals to 0.56 mole. So you will end up with the same answer again. The next problem is how many molecules are in 23 moles of oxygen. So we have number of moles which is given to us, and we need to find out that what number of molecules are in there. So we know that as per the convention says that 1 mole is equals to 6.02 times 10 power 23, and we have 23 moles, so that will become a multiplicative factor. How it becomes a multiplicative factor, let's do it in a ratio method. So we have moles and Avogadro's number. So 1 contains 6.02 times 10 power 23. So 23 moles will be how much? That is x. So x is equals to 23 times 6.02 times 10 power 23. That is why I was saying it becomes a multiplicative factor, times 6.02 times 10 power 23. And the answer is a very big number. So that very big number is 1.38 cross 10 power 25. So these are the number of molecules of oxygen that are present in 23 moles of oxygen. So let's find it out in method number 2. So method number 2 tells us that the number of moles, this is equals to given number divided by the Avogadro's number. Now we have the number of moles with us, we know the Avogadro's number, so we kind of move this Avogadro's number on the other side of the equation to find out the given number or the number of molecules. So the number of molecules, this is equals to, we can slash it as number of molecules. This is what we are working on. So number of molecules is equals to number of moles times the Avogadro's number. You see, this becomes a multiplicative factor. So again, it is 23 multiplying with 6.02 times 10 power 23. So we get the answer, which is exactly the same, 1.38 times 10 power 25. So in these two problems, we did mole and let's move the shape of this into this. We did the mole and Avogadro's number interconversion. Let's solve the other problem, which is a little mixture of mole and mass and Avogadro's number, how the three of them could become a matter of investigation in a certain kind of practice problem. So now we will be looking at the two different methods in a one cumulative problem. So how many molecules are in 25 grams of ammonia? So they are inquiring about molecules in 25 grams of ammonia. Before that, we were provided with the moles, but now we are provided with the grams. So this problem should be done in 2 steps. In the step number 1, we will find out that what number of moles are there in 25 grams of ammonia. Okay, why we don't find it out in 25 grams, rather we need to convert this into number of moles. So since the convention says that moles is equivalent to certain number of molecules, which is Avogadro's number, so definitely we need to convert these grams into moles first. So our first step, that is the step number 1, which is we need to convert mass into number of moles. And how do we do that? We have the very same triangle, and the triangle says when we have number of moles as a subject that we need to find out, then the other 2 quantities, they will be, since they are one above each other, so they make a divided function. So number of moles, this is equals to mass divided by mR. That is the formula we are going to use. But we are provided with the grams. We have the grams. We need to find out the mR. So we are provided with the substance. We know that substance. So how will we find out its mR? So first, we are going to find out mR of ammonia. So 1 cross the atomic mass of nitrogen, which is 14, plus 3 cross the atomic mass of hydrogen, that is 1. So 14 plus 3, this comes out to be 17 grams per mole. So number of moles, this is equals to given mass, grams, divided by 17 grams per mole. So what do we get? We get 1.47 moles. Since grams will be cancelled out by grams, we are just left with moles. So we have number of moles. In the step 2, we will be finding out that what number of molecules are there. So we will be using the first method, which is a ratio method. And the ratio method tells us that we have a mole and Avogadro's number relationship. It tells us that 1 mole is equivalent to 6.02 times 10 power 23 number of particles. Here in this problem, it is molecules. So 1.47 will contain how much? That is x. So x is equals to 1.47 cross 6.02 times 10 power 23. 10 power 23. So what do we get? We get 8.85 times 10 power 23 molecules of ammonia in 25 grams. You see, before that we have the practice questions which are based on a single step calculation, and in this problem we have calculations which are in 2 steps. Okay, let's do another practice questions. How many grams are in 8.200 cross 10 power 23 molecules of sodium iodide? Sorry, nitrogen iodide. So now we are going to find out the grams. We are provided with the number of molecules. This is the thing that is provided to us, which is a given stuff. you can take this as a given stuff. So again, now we are going to find out the number of moles first, because molecules has its direct relationship with the number of moles. So when we find out the number of moles, we can work out the grams. So in step 1, we will be finding out the number of moles using the number of molecules. So we will be converting number of molecules into moles. So we have a ratio method. Mole ratio is the Avogadro's number. 1 mole contains 6.02 times 10 power 23 Avogadro's number of particles. So 8.200 times 10 power 22 will be equivalent to how many moles? That will be x. So x is equals to 8.200 times 10 power 22 divided by 6.02 times 10 power 23. So what do we get? Let's find it out. So we have 8.200 times 10 power 22. This is divided by 6.02 times 10 power 23. So what do we get? We get 0.136 moles. This is what we get. This is the number of moles we have. Now in order to find out the grams, since we have number of moles here and the triangle says that there should be MR value, so we need to find out the MR. So in step number 2, we are going to convert number of moles into mass, and for that we will be using a formula which will be mass is equals to number of moles times MR. So first we need to find out what is the MR of nitrogen iodide. N2I6, this is equals to, we have 2 cross the atomic mass of nitrogen, which is 14, plus 6 cross the atomic mass of iodine, which is 126.9. So what do we get? 2 cross 14 plus 6 cross 126.9. We get 789.4. Now mass, this is equals to number of moles times MR. This is grams per mole. So number of moles is 0.136 mole cross 789.4 grams per mole. What do we get? This mole cancelled out by this mole, and we will be getting 0.136 cross 789.4. We get 107.4 moles, sorry, grams. We are finding out grams, so we get grams. So this is how you will look and work out in your practice problems. For this, you first need to understand the relationship they are asking about and the relationship, the components of the relationships they have given to you. If they have given you a direct relationships components, then that will be very easy. It will be a step 1 process. But if they give you components of the relationships which requires two steps or two different approaches, then you will have to perform a two-step process to work out the final answer, which will satisfy the question. The answer will be in the way that it satisfies the problem. So I hope we are very much clear about these problems. A worksheet will be provided on demand. So bye bye.